Okay, students, now welcome to lesson 7. And here we're talking about linear inequalities. Um, so, linear inequalities, like an equation, but an inequality. When we think about a lot of things in life, we don't need the exact answer. Do I have enough money in my wallet? How much gas do I need to get to such and such? Um, I'm riding at Six Flags, I gotta be at least 48 inches tall. I could be 48 or higher. So there are a lot of examples in life that have to do with inequalities, and they could be modeled with what's called a linear inequality um, algebraic expression. So here, this symbol means less than. Remember, the symbol always points to the value that's further to the left on the number line. This is called the less than, and then we have greater than, less than or equal to, greater than or equal to, and not equal to. So what does this mean? Well, would 1 work? Yes. Would -5 work? Yes. Would 2 work? Well, no, because 2 is not less than 2. Would 0 work? Okay. Yes, it would. Would I work? No, it's not a real number. Okay. So now, how would I graph that on the number line? Well, I would 2, 3, and then I've got a 1. Now, the 2 is not included, so I would do an open circle and to the left. You may remember that from high school. But there is another way to show these items on a graph, and there's another way to write them. It's called interval notation. Let me explain how that works. Alright, same thing. Here's the number line, and here's that 2. If I want to show everything to the left, not including the 2, I use a parenthesis for not including. And then I show an arrow going to the left. How do I write that in interval notation? Now this going to look like a coordinate for the coordinate plane, but no, what it is that, my friends, is interval notation. It means from -infinity to 2, but not including the 2. Now, if that 2 was included, we would use a bracket, not a parenthesis. That is called interval notation. All right, so when we're thinking about inequalities, here's one already solved. So all the values of, x less than 5. Now, we want to solve a linear inequality. It's like an equation. We subtract 3. So I'm going to subtract 3 from both sides. And I'm going to divide by 2. X is greater than or equal to 3/2. And I could graph it or I could show it in interval notation. Everything to the right of 3/2. Okay. Now what do I do when I have a negative sign in an inequality? That is a very good point. So let me ask you a question. Let's just play for values of x. You tell me yes or no. If x was -4, would that work? Well, that would be 8. 8 is less than 6. No, that wouldn't work. How about -3? No, that wouldn't work. How about -2? Is +4 less than 6? Well, yeah, that works. -1, that's 2. Is 2 less than 6? Yes. Okay, well, how about 2? Would 2 work? Well, yeah, -4 is less than 6. You notice it's going to be everything to the right of -3. Now, watch what happens if we divide by -2. Here's my x, and here's the -3. But I said to the right of the -3, and this symbol is saying to the left of the -3. So what happens is when you're multiplying or dividing by a -1 in an inequality, you have to reverse the order of the sign. Could I graph that? Sure. -3. It's not included. Everything to the right. It's pretty straightforward. I think that's all I want to say on that. Now, how about a compound inequality? You could do an and or an or. Okay. Well, you say this 3x plus 1 is greater than or equal to negative 2 and less than 10. So we just subtract 1. That's 3x is greater than or equal to negative 3, less than or equal to less than 9. Now I want to divide by 3. That's the only way I'm going to get the x by itself in the middle. So I'm going to divide everybody by 3. And here I have x is greater than or equal to negative 1, less than 3. Can I graph that? Sure. Could I do interval notation? Sure. Let's see, the negative 1 is included. It stops at 3, but the 3 is not included. Again, that's interval notation for that answer. That's basically it on that. Just some examples. Maybe that'll help you out. Thanks.